Hello again. Let's talk about non-probability sampling. As the name states, non-probability sampling is a technique used to collect samples without the use of probability theory. Now, if you've been watching these videos, you would know that samples collected with non-probability techniques are very likely to be biased. And because we are using non-probability sampling, we are likely to use methods where we choose who is being selected to the sample, or participants choose to select themselves in the sample, and therefore systematically, or we systematically include or exclude elements from the population. Therefore, we introduce bias in the sampling process, and we end up with a non-representative sample. So, non-probability sampling has a place in survey research, but should only be used when probability sampling is not an option. And this would be in cases, for example, where we do not have a sampling frame to sample from, right? Only in those cases where we cannot use probability sampling should we move on to non-probability sampling, but knowing that the results that we're going to get are not going to be representative of the population. One thing that I would like to make very clear is that the bias introduced in non-probability samples, right, will remain there regardless of the sample size, right? If we have a non-probability sampling technique that is excluding or including subjects or observations into the sample, then that systematic bias will remain there regardless of the sample size, right? Even if it's 10 or a million, if the systematic process of picking the sample is introducing bias, then the sample will be biased and non-representative, regardless of its size. Because bias is introduced in the sampling method, right? It's not a function of the sample size or even the composition of that sample, right? So, but like I said, with all these caveats, we can use non-probability sampling in, like I mentioned before, instances where we don't have a sampling frame or we don't have any other option but to use non-probability sampling. So in this video, I want to discuss 4 types of non-probability sampling. We will discuss convenience sampling, where the researcher relies on an available group of subjects or elements. Judgmental sample, where the researcher selects what he or she considers a representative subset of the population. We will consider respondent-driven sample, RDS, also known as snowball sampling, where respondents select other respondents. And finally, we will discuss quota sampling, in which respondents are selected based on some observable characteristic. So let's begin with convenience sample. And this is the one that is mostly used when non-probability sampling is employed. A convenience sample is one that is drawn from a part of the population which is close to hand. It is convenient, it's readily available right there. So it's also known as accidental sampling or opportunity sampling. So for example, if I wanted to do a survey of CHHS students, I will just survey this class because it's convenient, right? well, besides the ethical considerations of doing that, it would be very convenient just to survey the students in this class because I see them every week. So this sample, right? It would be easy, it would be convenient, but it would not be representative of the population because I am systematically excluding students that are not in that class. But it's convenient. Now, as convenient as it is, it will not give us a representative sample of CHHS students. Other examples of convenient sampling could be if a student wanted to survey, let's say, CSUMB students, and they survey the first 100 students that walk into the student center, right? That would be convenient. They'll stay there. There's high traffic. They survey the students there. Now, this would also be a biased sample because it's systematically excluding students that do not walk through the center. And those that walk through the center may be different than those that are not walking through the center. Another one could be, let's say, the mayor of the city of Marina wanted to know if Marina residents are happy with the library. So, so they surveyed the first 500 people that walk in the library, right? And this is a convenient. This is same as the other example. You can get the respondents right there, but of course, it's systematically excluding respondents from the city that do not visit physically the library. Another example would be I want to survey, let's say, 200 CSUMB students. So I post it on social media, on my Facebook page, and say, hey, whoever wants to participate in the survey, please click on this link. Now, that would be a convenient sample because all my friends and my friends' friends are probably going to see it, get to the link, but I is systematically excluding everybody who's not my friend or a friend of my friends in Facebook. So that would be a convenience sample, and it would be a biased sample. Now let's look at another type of non-probability sampling called judgmental sample. In this type of sampling, the researcher chooses, right, who they're going to survey, right? This is also known as purposive sampling. Now, this type of sampling is used when there is a limited number of subjects that have, let's say, special knowledge of the subject being researched, right? And so the researcher considers these subjects to be representative of the population because of their experience or because of their knowledge. But of course, this is biased by the researcher himself or herself because she or he is making a judgment of who knows and who is representative of this population. So, of course, that is systematically excluding or including subjects, and that is a biased sample. Another type of non-probability sampling is respondent-driven sample. And on this one, the researcher chooses a few subjects, and then those subjects are asked to pass the survey to other respondents, right? And those are asked to pass it to some other respondents. So that is respondent-driven sample because respondents are taking the survey to other respondents. It's also known as snowball sampling, right? You start with a small group and it gets bigger, bigger, bigger. Now, of course, this is introducing bias because it's systematically excluding those who are not known right, by these groups. But sometimes it's the only choice we have, right? When we don't have a sampling frame, when we have a list, or when the respondents are hidden, right? So, for example, imagine that you want a sample of CSU and Boost students that use cocaine, right? You're surely not going to find a list of all students who consume cocaine to use as a sampling frame. That simply doesn't exist, and students probably wouldn't want you to know they consume cocaine. They wouldn't want their name on a list. So, but you may know one student, and you ask this student to fill up the survey, and you ask this student to anonymously and confidentially pass this survey to another student who they know that consumes cocaine, and the ones that got the survey pass it to other students that consume cocaine. So in that way, you are getting responses from students that that consume cocaine, and without needing a list, right? Now, this is not going to be a representative sample because you don't know, right, the population, and you are systematically excluding some of the respondents or including some of the respondents, but it's the only way. So it is used for this type of research when the respondents are hidden or don't want to be found. Um, and it's the only way to get some information about them. Finally, let's talk about quota sampling. Now, quota sampling is a method used commonly, and is not to be confused with uh, stratified random sampling. In quota sampling, the researcher chooses elements based on some observable characteristics, right? And to make the sample representative in terms of those characteristics. So, for example, we want to survey um, residents of Monterey County. And we don't have a list of all residents of Monterey County, but we want it to be representative in terms of ethnicity. Let's say we know from the census that about 60% of residents are Hispanic or Latino, and 40% are not. So let's say we create quotas in terms of ethnicity. And in our sample, we're going to get 60% of our sample from Hispanic or Latino descent, and 40% from non-Hispanic or Latino descent. So we would have a sample that looks like the population in terms of ethnicity, right? Because we've purposefully collected students or subjects based on that on those quotas, on those observable characteristics, which in this case is ethnicity. So even though the sample will be representative in terms of this observable characteristic, it's still not representative in all, right? Because we are still collecting students or subjects using non-probability sampling from these quota groups. All right. Now, quota samples could look representative. They may seem representative, right? At least in this observable characteristic. And you can choose many quotas, like age and ethnicity. So you can get many groups within these quotas. And it may seem that the sample is representative, at least in these characteristics, but it's not representative in all characteristics. Certainly not representative of those characteristics that you don't observe, right? And whereas in random sampling or probability sampling, you would get a mix, right, of respondents on all characteristics, right? Because you're not systematically including or excluding respondents in terms of some unobservable characteristic. So an example of quota sampling, um, let's look at, let's say, going back to the previous video's example about a sample of CHHS students. Let's say the population is 100, right? And we wanted to survey respondents using quota sampling in terms of color, right? So in our population, we know that we have 65% yellow faces, 9% green faces, 22% blue faces, and 4% pink faces. So our sample of 10 students would have to follow this same composition, right? We would have to get about 65% yellow faces, right? And 9% green faces, etc. So we would choose, right? We would survey 7 yellow, 1 green, 2 blue, 1 pink, right? We would choose, and we would stop when we have the respondents that we met our quota of that type of respondent. We stop and we move to the next group, right? So in that sense, our sample would look exactly like the population in terms of the face color, but of course, it would not be representative in other characteristics, right? So you have to be aware of quota sampling because it looks like just like the population on the characteristics that you observe, but again, it is not representative because you've systematically excluded respondents on those characteristics that you don't observe. So, in summary, non-probability samples are not representative. It doesn't matter how large they are. It doesn't matter how careful you've been to, let's say, select quotas based on observable characteristics. They will still not be representative of the population. So they should only be used when probability samples are not a possibility, right? Like when you don't have a sampling frame, for example. But there is a place for non-probability sampling in exploratory research, in situations like I mentioned where probability sampling is not an option. But they are not representative of the population. You cannot make inferences about a population with non-probability samples, right? So this means that you should always ask and read about how the sample was collected, how respondents were chosen or not chosen, right, to participate in the sample before you make inferences about a population. And if the sampling method was non-probability based, then you should be very, very, very careful about making conclusions about a population from that sample. Anyway, this concludes our series of videos on sampling. I will see you on the next topic. Take care.